Hello class, and welcome to our first video in the series about matrix operations. A matrix is a rectangular array of numbers, symbols, or expressions arranged in rows and columns. And anything can really be put into a matrix. Now this picture might seem a little complicated, but a matrix can be any number of dimensions. So you notice we go like 1, 2, 3, 4, all the way to m number of rows. And then we have 1, 2, all the way to n number of columns. The dimensions of a matrix are rather important, especially when we get into doing some operations and things like that. And you always name a matrix according to its rows and then its columns. So in this case, it would be m by n. But let's come up with a few just basic matrices, like this one. If I have 2, 3, 4, 5, 7, 8, let's say this is my matrix. There are 1, 2 rows, and then 1, 2, 3 columns. So this would be a 2 by 3 matrix. Or you can have a matrix that's simply like a row matrix where it's just 1, 2, 3. This would be a 3 row by 1 column. We sometimes call this a row matrix. We sometimes call this a column matrix because it's just a column. And then conversely, we could have like 1, 2, 3, like this. This would be considered a row matrix because it's just one row. And you would call this a 1 by 3 matrix. And each number in the matrix has a position. So if you're in row 2, we go to this one. If you're in row 2, column 2, that would be position 2, 2. Or if you're in row 2, column 3, that would be the position 2, 3. Sometimes each number in a matrix is referred to as an element. So I could ask you at any time, what is the element in position 1, 3? And you would go to the first row and then the third column, and you would tell me 4. Just like with vectors, you can add and subtract matrices. One thing to make note of is that vectors, not vectors, matrices have to be the same dimensions in order to add them or subtract them. It's just not possible to add or subtract matrices that are of different dimensions. So if you want to add matrices, all you really have to do is just add the numbers in their corresponding positions. So position 1, position 1, position 1. Position 4, A4, B4, it's A4, B4. And the same with subtraction. Just make sure you watch your negative signs. When you subtract two matrices, you are subtracting the numbers that are in the exact same position. Let's do a couple of examples. So first, check your dimensions. Your matrices do not have to be squared to add or subtract them. They just have to be the same. So I have 5 plus negative 8. I'll go ahead and write this out. And then in this one, I have 4 plus 4 for my position right here. And then I have negative 7 plus negative 3 for this position, and then 6 plus 0 for my final spot in row 2, column 2. So now it's just simple math. 5 plus negative 8 would be negative 3. 4 plus 4 is 8. 7 plus negative 3 would be negative 10. And then 6 plus 0 is 6. And you have added your matrices. Again, this isn't very hard to do. It's just very easy to mess up. especially when you're subtracting. So make sure you're being careful about your negative signs. Now, example B here, if you notice, I have a 2 by 3 matrix, but here I have a 3 by 2, 3 row by 2 column matrix, which means I cannot add these because they're not the exact same dimensions. So you cannot add. And sometimes we like to get a little fancy with the things we put in our matrix. So even though this matrix looks very complicated, we can actually add the matrices, or in this case, we're subtracting. So again, be careful when you're subtracting matrices. Watch your negative signs. I won't write it all out this time, but maybe I should. So this is a 3 by 3 matrix and a 3 by 3 matrix. So our answer is going to be a 3 by 3 matrix. So in my first position, I have x plus y plus 2x. In my next position, I have negative y. See, I already messed up my negative signs. Minus y. And sometimes it helps to cross them off as you go. Then in my next position, I have x minus 3x. And then in my next row, I start with 3x minus negative 3. And then negative 9 minus 12. And then negative 2 minus negative 5. And then in my last row, I have negative 3x minus y. And then I have 4 minus x. And then the big one, 4y minus x minus 2 plus 3y. Now it's just a matter of combining like terms in each position. So here the x's cancel, and I'm just left with y. Here I have negative 2y for my second spot. Then x minus 3x is negative 2x. Then 3x minus negative 3 is 3x plus 3. Negative 9 minus 12 becomes more negative at negative 21. And then minus a negative becomes a plus right here, so that makes positive 3. Then 3x minus y, I really can't do any, or negative 3x minus y. Can't do anything there, so it just stays the same. The same with 4 minus x, it just stays the same. And then here, distribute your negative sign. And I'm going to end up with y, 4y minus 3y, minus x minus 2. And that's adding matrices. And subtracting. Also, like vectors, you can multiply any matrix by a scalar. Scalar is just a plain normal number. So your scalar here is just represented as c. And you notice sometimes we just write it out front of the matrix. Otherwise, we use the notation c times the name of the matrix, which is typically a capital letter. That c just gets multiplied to each element in the matrix, no matter how many elements you happen to have. So if I look at an example, what's 4a? That's 4 times matrix A, and matrix A is 3, 2, 5, and negative 1. So that just means each element in A gets multiplied by 4. You can almost think of it as the distributive property if you would like. So you have 4 times 3, which is 12, 4 times 2, which is 8, 4 times 5, which is 20, and 4 times negative 1, which is negative 4. It is also important to note that order of operations still applies with matrices. So when I say what is b minus 2a, I need to make sure that I am performing my order of operations correctly. I have 0, 2, negative 4, and 4 for matrix B, minus 2 multiplied by matrix A, which is still 3, 2, 5 and -1. You can do it in 2 steps or 1 step, but it is very important that you pay attention to the fact that each number has to be multiplied by 2 before you add matrix B or subtract it from matrix B. So I'm going to go ahead and distribute my 2. If you would like, you could also distribute -2, but I think I'll just keep it as subtraction. So this is 2 times 3, which is 6. 2 times 4, or 2 times 2, which is 4. 2 times 5, which is 10. And then 2 times -1, which is -2. And then, now I can subtract my numbers. So 0 minus 6 is -6. -4 minus 4, well, that's just 0. Nope, it's not 0, it's -8. See, watch your negative signs. Sometimes it helps to write it out. Then I have 2 minus 10, which is -8. And then I have 4 minus -2. 4 minus -2 will be 4 plus 2, which is 6. And that is your intro to matrices. Feel free to rewind and catch anything you missed. And as always, make good choices.